Welcome to Module 2, Lecture 2A, Tree Spacing and Row Arrangement from the web-based course, Pine Silvopasture in the Southeast. While traditional forestry plantation may involve planting up to 1,000 trees per acre, trees established in a silvopasture starting from an existing pasture are planted at much lower densities. A healthy planting range for silvopasture establishment is typically between 200 to 400 trees per acre. While this idea might seem counterintuitive for your traditional plantation forester, your ultimate goal is to produce high-quality saw timber in the long term while leaving open space within the system to graze livestock for short-term income. Another way to create a silvopasture system is to manage evenly spaced trees throughout the whole field, as typically represented by a plantation initially planted at a traditional forestry spacing. In this case, the trees are thinned to reduce the canopy and allow the development or establishment of understory forages. By growing trees in lower density stands, tree diameter growth is accelerated due to reduced competition from closely planted neighbors. Proper tree pattern will produce larger logs. For harvested logs, or stumpage, size is valued more than the number of rings per inch. Therefore, more open-grown trees can yield higher diameter logs more quickly. You might say, well, open-grown trees are going to produce more branches that will reduce the quality of my harvested logs. This is true. Open-grown trees in a silvopasture will require periodic pruning to get at least 16-foot clear logs for saw timber. We will address this more thoroughly in Module 4. Lower density stands permit enough sunlight to penetrate to the forest floor to stimulate forage growth. Canopy density in a silvopasture system is generally managed between 25 to 60% for cool and warm season forages, which lengthens the forage growing season and increases forage quality. Shade also allows cattle to graze throughout the day with reduced sun stress. In some areas of the southeast, well-managed silvopastures may be grazed almost year-round with minimal supplements for cattle or livestock. Silvopastures involve spacing trees that allow both forage and timber to thrive. The diagram shows an 8x8 tree spacing between trees and between rows, with 40-foot forage alleys between the pairs of tree rows. This arrangement yields roughly 250 trees per acre. In studies, double rows on an 8x8x40 or 4x8x40 foot spacing have yielded more wood than other planting arrangements. The spacing between trees or tree rows should be wide enough to get equipment in for haying, fertilizing, and access for future and thinning or harvesting. Generally, wide alleys between tree row sets support higher levels of forage production than closely spaced rows. Silvopasture trees can be arranged in uniform block plantings, clusters, or in single or multiple rows. Evenly distributed trees in block plantings optimize the growing space and light for both trees and forages. Trees grouped in rows or clusters concentrate shade and root effects and provide open spaces for pasture production. While triple and quadruple rows have been used in silvopasture, it has been found through research that middle row trees typically grow more narrow and have poorer quality due to competition from the outer row trees. Therefore, double or single row systems are considered optimal. When setting the width of the alleys between tree row sets, make sure you consider the width of the equipment that will be used in the management of the forages and plant the width of the alleys accordingly. Make sure you can get those hay balers, tractors, or mowers into the forage alleys with enough room to maneuver. As trees mature, the canopy closes between rows. Therefore, pruning and thinning of the timber component becomes necessary as a management priority, typically 5 to 10 years after seedlings become established on a site. Canopy density in a silvopasture system is generally managed between 25 to 60%, again to manage for both cool and warm season grasses, which provide larger open spaces for forage production, grazing, and overall management. Once established, both forages and trees coexist and can contribute to a highly productive silvopasture system. Research has shown that legumes under a pine canopy perform better than legume forage in open areas. The more open structure and plant diversity of a well-managed silvopasture are also attractive to many wildlife species such as turkey, deer, and quail. Site conditions and producer objectives, in summary, should ultimately dictate the desired planting arrangement. Whether you choose a single or double row system to establish silvopasture in existing pasture or convert an existing forestry stand, proper tree spacing and row arrangement is key to the production of high-quality forage in the short term and saw timber in the long run. Welcome to Module 1, Lecture 1B, Economic Considerations, from the web-based course Pine Silvopasture in the Southeast. Silvopasture systems reduce economic risk by producing multiple products. For years, range scientists have advocated combining cattle and timber production on the coastal plain of the southeastern United States. While low-density grazing of native forage in natural forests and plantations is practiced throughout the southeastern U.S., few landowners are aware of the economic potential of combining forage and timber management practices. Economic analyses have shown that intensively managed silvopasture systems can be more profitable than traditional systems. Livestock production, which benefits from shade grazing and managed forage, serves as an annual income source, while saw timber is produced and managed for a high-quality product in the long term. Grazing may also be a way to reduce fuel loads, reducing the risk of fire, keeping fire risk low, and eliminating the need for chemical or mechanical competition control. A well-known study in the 1980s by Dr. Terry Clayson of the internal rate of return of a silvopasture system compared to traditional forest plantation management and managing coastal pasture lands for grazing indicated a higher return for silvopasture. Dr. Clayson found that a loblolly pine forage intercropping system is a suitable management option for maturing plantations. After 5 years of study, he determined that timber and forage management practices provided investment income, created and maintained a high-quality forage resource, and enhanced the timber production component. While less trees per acre are managed in a silvopasture, the production of higher quality saw timber is the ultimate goal, which can provide an overall net gain at the end of the timber rotation at 22 to 35 years, depending on tree growth, site quality, and the intensity of management. Proper silvopasture establishment requires several initial and long-term cost considerations. Site preparation prior to planting tree seedlings as well as annual management costs are required for a successful silvopasture system. However, these production costs are reduced and marketing flexibility is enhanced by distributing management costs between the tree, forage, and livestock components, each of which have their own associated costs and benefits. A number of factors can influence initial establishment costs. Landowner objectives for the land will definitely impact costs, as well as the existing state of the pasture or plantation which is being converted. Well-maintained pastures may only need minimal site preparation, while overgrown pastures or young forests will require substantial weed management, prescribed fire, or manual and/or mechanical clearing. The cost of seedlings will also vary depending on your seedling source and whether the seedlings are bare root or containerized. You can pause this presentation to take note on some of these associated costs. For example, herbicides and labor for removal of competition and weed management can be anywhere from $50 to $250 per acre, depending on the type of application used and the condition of the site. Prescribed burning can vary anywhere from $20 to $25 per acre. Tractor equipment costs vary. On old agricultural fields, disking and subsoiling might average $25 to $50 per acre in fuel costs and labor. Or on cutover forest land, this amount could equal $100 to $150. Cost of seedlings equal $40 to $75 per thousand bare root seedlings, or $100 to $125 per thousand containerized seedlings. And labor for planting, if you hire it out, can be anywhere from $35 to $45 per acre for your southern pines. There are a number of annual costs that are also needed to be considered and planned for. Annual costs may include herbicides, which may be required after trees are established to manage competition, Tree pruning is an essential element of silvopasture which may begin around 5 years after planting and will need to take place around every 5 years to keep the canopy levels below 50% and to remove the branches that cause knots in saw timber. Fencing and maintenance costs will include the initial costs of fixed or portable fencing plus periodic repairs. Fertilizer and lime applications are typical annual costs for any agricultural production operation. Portable or permanent watering facilities for livestock will need to be accounted for, as well as seed for forage or other annual crop to be planted within the silvopasture alleys. There are also the costs associated with pre-commercial thinning, which may be recuperated if the price for pulp is high enough to show some gain. Forage establishment and management costs are presented here as ballpark figures. An individual landowner may or may not require all of the inputs here, and costs are dependent on existing labor, equipment, and the overall fertility of the site. For example, starting from scratch with seed plus planting costs and paying for labor and use of equipment could equal up to $275 per acre. Annual nutrient fertilizer costs might equal $85. Annual hay harvesting costs could equal $20 per ton, or around $60. And periodic lime costs around every 5 years might equal around $24. These are just some estimates of costs for forage management. There are some important points to consider regarding forage management economic savings. Stress on cattle can decrease efficiency by as much as 20%. Therefore, if the average feed bill on an open pasture is $150 per animal unit, a silvopasture system can save the grower, the farmer, around $30 per animal unit annually due to reduced stress. The increased grazing period resulting from a well-managed forage rotation, less affected by early fall or late spring frosts, can reduce feed costs by as much as $25 per animal unit per year. There are also savings in fertilizer and herbicide costs and nutrient cycling. Grazing can also eliminate the cost of mechanical or chemical competition control in mid-rotation pine plantations. Trees can also cut the direct cold effect on cattle by 50% or more and reduce wind velocity by as much as 70%. Reducing stress on animals translates into financial gains. Technical assistance may be necessary to develop a system that will function effectively and cost efficiently. State and federal programs may be available for financial assistance with tree planting or thinning or pasture establishment. The WIP program, or the Wildlife Habitat Incentive Program, provides a 75% cost share for forest stand improvement. It, however, does require a 5 to 10 contractual agreement. The FLEP program, or Forest Land Enhancement Program, is a 75% cost share program as well, which lists, quote, enhancing implementation of agroforestry practices, unquote, as one of its 7 primary objectives. As of 2007, FLEP allows a treatment of up to 1,000 acres per year, and the maximum FLEP cost share payment for any practice may be up to 75%. It is important to contact the Natural Resource Conservation Service for details on these programs. There are also multiple land use tax breaks and incentives for forest management that vary from federal to state to county levels. It is prudent to get in touch with your NRCS district conservationists and county farm service agency representatives to see what silvopasture establishment and management may qualify you for. In summary, there are some more regular management costs of a silvopasture system that differ from traditional grazing and forestry operations. While upfront costs to convert to silvopasture may seem initially high, the benefits of this integrated system can yield a higher overall return. Welcome to Module 1, Lecture 1A, a snapshot of silvopasture, from the web-based course, Pine Silvopasture in the Southeast. Silvopasture integrates trees, livestock, and forage into a single system on one site. Silvopasture is becoming an important land management strategy on many farms and ranches in the southeastern United States. It is becoming more important also on farms and ranches where coniferous trees exist in other parts of the country. These components diversify income sources. Annual income from grazing and long-term profits from trees respond to different market pressures and reduce risk when combined in the same operation. While you might see cows grazing in an unmanaged woodlot, this is not considered silvopasture. While silvopastures can be custom designed, they must have 4 key characteristics which are the essence of silvopasture and distinguish it from typical grazing or other forestry technologies. Silvopasture systems are intentional, intensive, interactive, and integrated. In other words, each silvopasture ingredient is purposefully managed to yield multiple products and benefits. The system must be regularly and deliberately managed, and the resources are managed to optimize desired effects and to mitigate any undesired effects. The goal is to enhance production of more than one harvestable component at a time, while also providing conservation benefits like non-point source water pollution control or wildlife habitat. The understory trees, and the animals and the forage are structurally and functionally combined. The 3 major components of any silvopasture are the trees, the livestock component, and the forage. Locally marketable tree species can provide significant long-term income. Trees must be fast-growing, deep-rooted, drought-tolerant, and respond well to pruning. Trees also provide wildlife habitat and store carbon. Module 3 will cover the tree component in more detail, primarily the main species for silvopasture plantings in the southeast. Silvopasture systems primarily involve cattle, goats, or sheep as the livestock component, but there are other livestock options available. Module 5 will cover cattle management in more detail. And regarding forage, there are a variety of plant types including shrubs, grass, legumes, and forbs which can make up this component of a silvopasture. The choices depend on the livestock component, and species chosen must be tolerant of grazing and be productive under shade. These will be covered in more detail in Module 6. Silvopastures can be initiated by planting trees into existing pasture or by thinning an existing forest stand enough to open up the canopy to allow sunlight to reach the forest floor or the soil to encourage the growth of grasses and forage species. A pine silvopasture is grown in a much lower density than a traditional forestry plantation is established. Many silvopastures start with around 300 to 400 trees per acre and are periodically thinned to around 50 to 150 trees per acre for a final harvest of high-quality saw timber. Because trees are grown in a more open environment and at a lower density than a traditional forestry plantation, pruning is a management necessity to produce high-quality timber. Pruning removes branches that form undesirable knots that form and can degrade the quality of saw timber. Module 4 will cover more details regarding pruning and thinning. Proper forage management and forage species choice is essential. Forage species must be suitable for livestock grazing. They need to be compatible with the soil and the site. They should be productive under partial shade and sometimes moisture stress, be responsive to intensive management, and also tolerant of heavy utilization. In a silvopasture system, livestock are managed for annual or short-term income. And now the shade from managed trees and good forage management make for healthier livestock. Grazing animals control competition for moisture, nutrients, and sunlight and can enhance tree growth. The livestock manure recycles nutrients. Silvopastures provide that shade and wind protection, which can increase livestock performance, and the uniformly dispersed trees can increase livestock comfort levels and reduce their stress. Producers can either use continuous stocking systems or rotational grazing to maximize the efficiency of their grazing operations. Pastures are normally divided into fenced paddocks with strategically placed water sources to optimize the system. Grazing time within each paddock should be according to forage growth, not on a fixed time schedule. Animals must be moved to new paddocks before they graze new regrowth of the current paddock. Salt and mineral licks must be strategically placed to encourage uniform livestock distribution. In summary, a well-managed silvopasture can provide a lot of different benefits. They diversify on-farm income. Silvopastures provide annual income from grazing and long-term profit from trees, which respond to different market pressures. Silvopastures increase biological diversity. They help protect water quality, reduce soil erosion, and can improve the water holding capacity of the land. They also provide wildlife habitat by creating structure and plant diversity, which is attractive to many wildlife species, including wild turkey, red-cockaded woodpecker, and deer. Silvopastures also boost the property values of land by boosting the opportunity for recreational activities, and the alleyways that are typically created in a silvopasture are easily accessible for hunting, bird watching, photography, and other recreational land uses.